Hello and welcome to this part of our video series. If you are building on the applications that we had so far, and actually there was just one application so far, but guess what? It's going to get a little more complicated now. Take, for example, a beautiful building. It starts from a basic foundation and we build on top of it. We build the walls, we do the wirings, we do the plumbings, and we do the facade and the lawns, and at the end we have a beautiful house. So this is a foundation that we are building on top of it. And guess what? This sounds like what we are going to do now is like taking care of the basement. And that's very important. That's a very basic in foundation of the building. So what I mean by that is that we are going to now, so far we were using the hard-coded data. And now we are going to replace that with live data. So how it's done in the real world is that this service either is going to call a database, most likely, or another service, most likely. And it doesn't do that directly. Usually it does that through a remote layer or a DAO or a repo layer. So but we are at the first step at this project, we are going to actually go the database route. It's a little more complicated, but it's a real world example of how things are done in real organizations. And it's important to know that. So how we are going to do this is that we need a database, first of all. And then we need some way, an IDE, if I may say, to connect to that database and create our database, create our tables, manipulate our tables, view the data. So, well, in real world, we have databases like Postgres, Oracle, and if I may say, MySQL, especially if you are into clouds, MySQL is um, a very good option. And then they use IDEs like Toad, uh, and for example, uh, like if I may say, dbeaver to connect to that database as an IDE. For our example, we are not going to go that route. It's a little more complicated. We're going to do something simpler and but something more techy. So by that, I mean you are going to tap into the container world for this and do it in such a way that you will appreciate how easy it becomes to set up um, databases using containers and connecting to them. We use a Docker image for Postgres and run that Docker image locally, and then we connect to it with the client, database client that exists in IntelliJ. IntelliJ comes with a very neat way of connecting to the databases. And you don't even have to have the professional version. The community version would do. So very well, then let's jump in. What do we need for this to happen? First of all, we need to install the Git because uh, Git comes with Git bash, which we can run Unix command like on it. And once we have that, we need to install a Unix type of uh, environment in our Windows laptop if you are working on Windows uh, or if you are working on Mac, for example. I haven't worked with Mac recently, but I believe that comes with a Unix environment on its own. For Windows specifically, we use WSL2. And on top of that WSL2, we installed Docker Desktop. Docker Desktop is a Docker dashboard that works for Windows. And it makes Docker features available to us to execute. So here we are. We are, if you look over here, we start with the git bash. We install the WSL. Then on top of that, we install the Docker image. And it's very easy to start a Docker image. You go over here, you look for Docker desktop, and I'm sorry, I said Docker image. I meant Docker desktop. Yeah, and you just click on it, and we are in the business. And this is WSL that we installed to make Docker desktop work on our laptop. So I don't go through the detail of installations. As I told you, these are boring things. You can figure it out. There is tons of information out there how to do this. Um, so let's go back to what we need to do now. So having these utilities, I'm going to open the yeah, I'm going to open the git bash. I'm going to actually run this command that I've already saved to um, and you can see that Docker is already running. However, Docker doesn't have any containers right now in it, and nothing is running. So, um, and I will come back to this once a container has been created from Postgres. So here I have this information available. As you can see, I am using Docker to create a container called Postgres demo. And this is a database. The image of it is Postgres. Uh, and basically, I'm doing some mapping over here for the ports. I'll get into this detail when I start talking about Docker in future videos. But this database are going to have a name, EmployeeDB. I'm going to have a user, this Postgres. Well, how about I change the user and make it my own name? And because I'm going to be the user actually, how about that? The password, let's just keep it simple. And let's actually create a database from a database that's when this image is running. So we are not going to just create a database in this. So let's run this and see what we get. So the image was downloaded and created. And if I go over here, you see that I have that image, that container, post demo. And this is the image name, okay? And everything that you see in my command is reflected here. I would like to start this. Looks like it started already because I have used the run command over here. So this is a container that right now is running on my laptop. And wonderful. And as I told you, I'm going to explain this in detail later. So it seems a little confusing to you if you don't have any knowledge about Dockers. But if you do, then I have already talked too much about it. If we come to IntelliJ and we go to database view over here, you see on the side. All right. Now, this is the connection that I already created for Postgres. All you have to do, you have to go over here and create this connection with the data source from the template and um, connect to it then. So here we are. And it looks like we have changed the credential. Yeah, the user is myself now. Okay, looks like we're connected. Very well. And let's open up a query console over here. See how neat this is. Up here, you see the databases that exist over here already. I'm going to create my own database, right? So let's call it, um, let's create this database, call it employee DB for simplicity. And we execute this. We created the database employee DB. So if I go up here, you should see the database employee DB. And This is the confusing part of some of these client IDEs with databases. Make sure you always are connected to the right database. Um, and then we go ahead and let's create a table in this database. So I have the database DB. I don't have any tables in it yet. So what I'm going to do actually is that I'm going to create this table employee in this database. Note that everything is the same as our data over here. However, I have added this ID as the primary key. So let me take one step back. I'm creating this employee to mimic the data or the POJO that I have created in this model employee. As you can see over here, this employee has an ID, first name and last name and age. So over here, I would like to mimic that. ID, first name, last name, and age. Employee ID is missing. I'm going to add that employee ID over there because this is employee ID is going to be what we be looking up the employee with. Usually this is an employee number. In different organization is represented differently. In some organization is a UUID. In some others is social security number. So I'm going to discuss about this a little further later when we get to the coding. But right now, going back to the console, I'm going to create this table. Hopefully it goes smoothly. Oh, well, table was created smoothly. If I now go back to tables and open this, you see the table was created. Wonderful. How about we add something like some information to this table? Let's say insert a record, if I may say. Insert into what is the name of our table employee, and let's say values. For ID, let's choose 1, and for employee ID, it's a varchar. Let's use 1, 2, 3, 4, 5, 4, 6, 5, 4, 3. It doesn't matter as long as it is 9 digits because we're going to be using the social security number. Later, we can add required validations for this. The first name is John, and the last name is Doe. I apologize if this is boring name, but to us developers, this is like a very common name to use for demoing. And the age, let's make this guy really young. Let's give him a 25 years of age. So when we execute this by control enter, it says is asking us to verify this statement, and it was executed. So if I go to this table, these columns are over there, and let's retrieve the information from this table. Say select everything from employee. All right, and yes, down here you see how neat this is. This is actually the social security number of the employee. His name is John Doe, and he's 25 years old. And guess what? Um, Everything went smoothly this time. I am not editing my videos, as you have noticed, and if something comes up, we solve it together. One thing I wanted to point out though, if I actually change this database, okay, and I execute this again, and actually, let's do it that way, you'll see an error. Employee doesn't exist. This is confusing, and I have seen this happen many times, even to myself. We have to be connected to the right database for this to work. So yeah, well, thank you for sticking with me for this interesting um, part of our presentation. We created the backend. We built the basement of our foundation, and now we're going to build on top of that. In the next video, I'm going to come back and create a repository, and use JPA and Hibernate to actually retrieve data from this table or add data to it. This is very exciting, and this is going to be something that's very much used in the other companies usually, and the ones that they use Spring Boot as the REST uh, framework. What they do is that they utilize this approach to um, connect to the database and manipulate the data or retrieve them. Um, in the next video, I talk about this more. Thank you, and see you soon.